they're so high maintenance. Okay, so when you guys set up the proportion, because I'm assuming we could set up the proportion just fine, right? It was the solving of the proportion that was the hard part. Is that, do we agree?
Yeah.
We agree. Okay, so what was the proportion we set up?
X plus 7 over 6 equals 24 over x.
Okay, and so then what did we end up multiplying? I wrote that funny. X times x plus 7. Okay, what is 6 times 24? 44 equals x squared, not 2x, it's x squared, right? Plus 7x. Okay, and then when you're solving a quadratic, you can't square root something, you can't divide by x, you can't do anything funky like that, you have to make it equal 0. We remembered that, right? Make it equal 0? Okay, so we're going to minus the 144 over. So we got 0 equals x squared plus 7x minus 144. And I always put my information in a little x like this. Does that look familiar? Did your teacher do that? Okay, you don't have to put the little x, that's fine. But that's how I organize my information. So I say I'm looking for two numbers that multiply to negative 144 and add to 7. That should sound familiar. Okay, multiply to negative 144, add to 7. That is what made the problem difficult because most of us do not know the factors of negative 144. Did your teacher last year teach you the calculator trick? Oh, the calculator.
Is it something with lists?
Yes, kind of.
You can just get the whole list.
You can get the whole list of numbers if you hit the y equals button on a graphing calculator.
Oh, yeah, you taught us.
I taught some people this yesterday, like 2 of you. Yeah. So if you go into the y equals screen and you do negative 144 divided by x, negative 144 divided by x, then you can hit second graph, and those are all the numbers that multiply to negative 144. So negative 12 times 12, that multiplies to negative 144. Negative 9 times 16, that multiplies to negative 144. Negative 8 times 18, that multiplies to negative 144. So we are looking for the pair that adds to positive 7. So we're ignoring any pair that has decimals. Yeah. So the X button is right here. So we're in the y equals screen, we're typing negative 144 divided by x. And then from there, we're doing second graph. And so the two numbers that we get that add to 7 are negative 9 and positive 16. So that, I think, was the hardest part of this problem, is just that a lot of us we would have maybe slightly remembered factoring, but getting those two factors that multiply to negative 144 and add to 7 would have been very difficult. So it is 16 and negative 9. And so then we have 0 equals x plus 16, x minus 9. Do we remember that? Vaguely from Math 1. And then do you guys remember how we get from there to the actual answers? Yes. Yeah. Yeah, so it's the opposite signs, yeah. So it's minus 16, positive 9. Now, we have two answers. We have to see which answers make sense. So one of the side lengths is just x. Does a negative 16 for a side length make sense? No. So negative 16 is out, not because you couldn't mathematically solve the problem that way, but because when we try to use that answer is nonsense. So negative 16 is just out. It just doesn't, it's silly. It's a silly answer. 9, however, as a side length is reasonable. 9 works. And 9 plus 7, that works. So negative 16 was nonsense, but 9 is pretty good. We like 9. All right. when we set up the proportion on the other one, what do we get? Okay, and so then when we cross multiply, what are we getting? 18 times 10 equals x minus 2 times x plus 1. Okay, so this is 180. And then how do we multiply two sets of parentheses like that? We FOIL them. And when you FOIL them, you get x times x is x squared plus 1x minus 2x. What is plus 1x minus 2x? Minus 1x, okay? And then minus 2. All right, so just like the other one, we have to make it equal 0. So we're going to minus the 180 over. So we get 0 equals x squared minus 1x minus 182. Just like the other one, it's a factoring problem, but it's a difficult factoring problem. You're looking for two numbers that multiply to negative 182, but add to negative 1. And most of us, off the top of our heads, don't know the numbers that multiply to negative 182. If they'd asked us for the numbers that multiply to 24, yes, I could have done that. Negative 182, let me get my calculator out. So I'm going to take my calculator again. I'm going to hit the y equals button. I'm going to say negative 182 divided by x. And I'm going to hit second graph, and I'm going to look at my options. So I'm looking for two numbers that multiply to negative 182, but add to a negative 1. I'm ignoring all the combinations that involve a decimal. Okay? There you go. Yeah, so this one is close, but it adds to positive 1. We want this version that adds to negative 1. So negative multiplies to negative 182, adds to negative 1. The two numbers that do that are negative 14 and positive 13. Do you have to show your work like that? No. I always do because it's habit for me to show my work like this. Okay, so now we have x minus 14, x plus 13. I am not going to expect you to remember this from these two review problems. We're actually going to do a review unit of quadratics, okay? So do not feel like you have to remember it from these two problems. You don't. All right, what are the two answers we get? Negative 13 and positive 14. And which one of those is valid based on our picture? Positive 14. Negative 13 is not going to work because we are talking about the lengths of a side. Negative 13, if you plug it in, negative 13 plus 1 does not make sense. Negative 13 minus 2 does not make sense. Because when you solve it, it changes the sign. Yeah. All right. Marvelous. Who wants to hand out papers for me? Because I do not feel like getting up. Oh, find EY. 14 plus 1. EY is 14 plus 1, which is 15. I didn't even notice that. My answer key is wrong. Oh no! You do? Oh no! Oh no! I have to go back and fix my answer key. Side lengths on some of them say solve for x, but some of them don't. Then you can do it. Yes, of course. Ugh. Thank you for pointing that out. Shouldn't rush, Miss Rice. Then you don't get your answers right. And then your students go, no, no. All right, go ahead and put your assignments in a pile. Okay, who's handing these out for me? Nobody? Anybody takers? Anybody will hand these out for me? Thank you. Thank you. Marvelous. Thank you. You guys, for a moment there, I was true. That would have been catastrophic. Can somebody, actually Asa, I think you're closest. Maybe Asa or Bentley. Can you guys look at the schedule and tell me when class ends for a half day? 9:18. Marvelous. Okay. It will, yeah. Not a nice clean, yeah. I know what you meant. Yeah. They're extras. All right. So, here are the notes for today. Triangle similarity. Triangle similarity. You might write that on the topic. Triangle similarity. But today what we're doing is we're actually proving it. This is how you prove that triangles are similar. All right, so when we proved that triangles were congruent, we were using that sides were congruent and we were using that angles are congruent. So today, if you notice, we have some things that are kind of similar to that. So with triangles being congruent, we had side, 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 angle, side, angle, side, angle, and hypotenuse leg. And when we referred to those, we meant that the angles were congruent and the sides were congruent. Today we're going to learn about angle similarity, which means that two angles are congruent. We're going to learn about side, 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 which does not mean the sides are congruent. It means the sides are proportional. So side, side, side congruence means that all three sides are congruent, therefore the triangles are congruent. Side, side, side similarity means that the sides are proportional, therefore the triangles are similar. Does that make sense? Different than side, side, side that we learned before, okay? And then the last one is side, angle, side, which means that two sides are proportional and one angle is similar. Does that make sense? Two sides are proportional and one angle is similar. And then you have side, angle, side similarity. Yes? So congruent means all the angles and all the sides are actually equal to each other. Similar means that angles are actually equal to each other, but the sides are just proportional. So the shape is the same, but they've been like dilated, enlarged, or yeah. Yep. Okay. So let's go ahead and go through these notes. All right. So in the first one, what I'm going to do is I'm going to start with examples 3 and 4 because I want to see why they can only say two angles. They said angle similarity instead of angle similarity. And I want us to see if we can figure out why you only have to have two angles are the same instead of saying all three angles are the same. Okay? So if we look at this one, they say this is a 90-degree angle and this is a 39-degree angle. This is a 51-degree angle, and that's a 90-degree angle. We want to know, is that enough to say those two triangles are similar to each other? So let's start by finding the angle measurement of S. So we're going to do 180 minus 39 minus 90. Let's find the missing angle. So if we subtract those, what do we get? 180 minus 39 minus 90. So are the two triangles going to be similar? What do you guys think? Yes. How do you know? So if I know that 51 is the same and 90 is the same, how do I automatically know the third one's going to be the same? Because it has to be the same as this one. Why? It has to equal 180. And if you have two are the same, there's only one way the third one can go to add up to 180. That's why it is angle congruence or angle similarity, because if you have two angles already, there's only one way that third angle can go. Does that make sense? So if you tried to say angle similarity, you're like, yeah, I could find all three angles, but I'm just wasting my time a little bit, because if two angles are the same, of course, the third angle is going to be the same as well. Does that make sense? Okay. So we're going to make sure, though, that when we use these, we don't say angle-angle congruence, we say angle-angle similarity. I am not trying to say these triangles are congruent. I'm trying to say that they're similar. So they're not equal in size. They're the same shape. But one is bigger than the other. They're proportional to each other. So I'm going to say, yep, and let me finish my work here. 51, 39. Let me write the 39 there. So I'm going to say, yep, they have angle-angle similarity. Now they want me to write a similarity statement. So I'm going to go ahead and write a similarity statement. I'm going to say SYE is similar to, if I did SYE, then what do I have to say? What order do I have to say for the other letters? I have to W, C, H. Okay. All right, let's do number 4. So let's find angle B. We're going to do 180 minus 68 minus 54. It's 58. Okay. So what do you guys know about this? What do you guys notice already? They are not similar. This is 68 and this is 63. 63 does not match 54 or 58, so I'm going to say not. I do not feel like writing the whole word similar, so I'm just going to say not similar. You could write no. That is the symbol for similar. Oh, yeah, can you do that or something? That looks like a fancy X, so I'm guessing no. I'm not sure. We can Google it. We can look it up and see. Not similar. I don't know, because I've never seen anybody, I've seen the not equal, but I haven't really seen somebody do that for not congruent. Did you see anything? Yeah? Okay. Yeah. AKA not similar. Similar with a through it. You like my sound effects? Similar with a. All right. Okay. Let's do these other ones. So we've got 2 parallel lines. And we've got, I'm going to use this one as the transversal. There's my transversal. Okay. So I'm going to go ahead and label, here's one alternate interior angle, here's another alternate interior angle. So those are the same. You can. And you can do vertical angles. And then we actually have another transversal. And then the other alternate interior. And so these are the same by angle, angle, similarity. And so you guys can't talk through the whole lesson. It's very distracting. You did very good innocent eyes when I caught you, though. It was nice. I liked it. All right, so we have triangle. Let's see. CDE is similar to triangle. What would it be? GFE. So based on the order that I did it, CDE was 3, 1, 2. So it'd have to be 3, 1, 2. GFE. Good. Okay. Here's our parallel lines on this one. What angles do we have with these parallel lines? And then here's one transversal. So we don't have alternate interior angles that we're using this time. What angle relationship are we using? Corresponding. Okay, so that's one transversal. Then And then here's the other transversal. Not same side interior. What are we using this time? We're still doing corresponding. Cool. So what we've got going on is we have a little triangle right here that has Q, P, and L. And then we have a big triangle that uses M, N, and L. So angle L is the same in both triangles, the little triangle and the big triangle. So we have angle, angle, similarity. And I'm going to say triangle LQP is similar to triangle what? LMN. Perfect. Okay. So if you did MNL, then it would have to be QPL. Okay. Now, 5 is a similar picture to number 2. Let's go ahead and see if they're actually congruent or not. So it's a similar picture, but they didn't tell us parallel lines, okay? How could we figure out if the two triangles are similar? Adding things and stuff? How do we do that? Okay. Okay. So 180 minus 91 minus, sorry, not minus 91. 180 minus 25 minus 67 is 88. So if this is 88, then is the whole triangle similar to the little triangle? No. So they are not similar. I still feel like I'm drawing a fancy X. For this part? The similar is a squiggly line. See, it's got to be squiggly. It can be less squiggly than mine. You could do a little bit, like see how this is less squiggly? Oh, yeah. So squiggly and then like that? Yeah, it's still, I don't know, because the not equal is still slanty. It almost has like swastika vibes. Yeah. I'm just gonna say not similar because I don't even wanna. Yeah, let's not go there. We're not trying to trigger anyone. We're keeping it safe here. We're safe space. All right, number 6. What do you guys see? We cannot do parallel lines and transversal like we did in number 1. We can do vertical angles though. Okay, so we're gonna say angle, side, similarity, and this is a picture where truly we can only conclude anything about 2 angles. Based on what we know, we're going to say, okay, I can conclude something about the 2 angles, so I know that the third has to add up to 180, but I cannot make any statements about the third because I do not have enough information in the picture. So I cannot say anything about the third. I don't have numbers to subtract from 180. They did not tell me anything about the third angle being congruent. I don't have parallel lines so I can make a conclusion about the third. So this is one where we truly are dependent on angle similarity. Like this is the only picture out of all of the examples where angle similarity is exactly what we needed. All right. So here I'm going to say triangle PQX is similar to triangle what? ZYX. Perfect. Okay. So that's how you do angle similarity. Are we comfortable? Marvelous. Okay. Side similarity. So here's how you do side. These ones are pretty simple because we are just showing that the sides are proportionate. So here's what I like to do. I like to take the sides from one triangle and just put them smallest to biggest, okay? Because all we have to do is set up the proportions. So I'm going to write 9, 13.5, and then 20.25. And then I put the other sides also from smallest to biggest. So the smallest is 14, and then 21, and then 31.5. Okay? Now, if these are proportional, then all of these fractions would simplify to be the same thing. They would have the same scale factor. Does that make sense? They would all be the same. So if you want to work with fractions, you can, but sometimes they don't simplify to a fraction. Sometimes they give us decimals, okay? Yep, yep. So 9 divided by 14, 13.5 divided by 21, 20.25 divided by 31.5. See how they all gave us the exact same decimal? So they are proportional. Okay? And my guess is with the other ones, so this decimal, if I hit the math button and turn it into a fraction, 9/14 is that simplified fraction. 9/14 is that scale factor. So this would be a 9 to 14 scale factor. Okay, it's a 9 to 14 scale factor. Okay, so yes, these are proportional. It is side, side, side similarity. Yes?
We don't know if they're exactly the same side because, like, all these are like, because the calculator doesn't
Nope.
show all the digits.
But look at all of them. They all match. And the way that you can tell is if you can take those fractions. So let me take this one right here, and I'm going to turn it into a fraction. If all of them can be turned into the same fraction, I can turn it into 9/14. That means that they're the same. So all of those fractions, this one was 9/14. This one could turn into 9/14. That one could turn into 9/14. If that is the case, that means they are proportional to each other. Okay, so let's go ahead and write that proportionality statement. So what I'm going to do here is I'm going to say 9 is across from R. I'm going to say that's the smallest. 13 is across from K, that's the middle. 20 is across from N, that's the biggest. So 14 is across from S, that's the smallest. 21 is across from D, that's the middle. 31.5 is across from E, that's the biggest. So whenever you have side lengths, the length of the side, the smallest length of the side is across from the smallest angle. The middle side length is across from the middle length angle, and the longest side length is across from the biggest angle. That's how it always works. So if you want to go after you know that your side lengths are proportional, Asa, are you writing this down? Okay, so your phone shouldn't be out at all. So once you know that your sides are proportional, if you want to go back and label your angles so that they're easier to write your similarity statement, that could be a helpful thing to do. Okay, so we're going to say, I'm going to write R, K, N is similar to what triangle? S, D, E. All right. All right, on this one, let's go ahead and add these together. What is 20 plus 8? 28, okay. What is 15 plus 6? Yeah, you were right, 21. Okay, so we're going to do the same thing. I'm going to use the little triangle right here, and I'm going to put the three sides in order. So 15, 20, 30. All right, and then I'm going to use the bigger triangle. And here I'm not going to do the sides in order. I'm going to, because I can already tell what sides are supposed to correspond to each other. So 15 is supposed to correspond to 21. 20 is supposed to correspond to 28. 30 is supposed to correspond to 42. So I can already tell what they're supposed to correspond to. Let's go ahead and type these in. 15 over 21, 20 over 28, 30 over 42. And if you can see that all those decimals are matching up perfectly, then we can tell that those are proportional. Let's pick one of those fractions, and what I'm going to do is I'm going to hit the math button, turn it into a fraction again, and the calculator is going to simplify that fraction for me so that I know what that scale factor is. So this is a 5 to 7. The little triangle's the 5, the big triangle's the 7. Okay, it's a 5 to 7. So I'm just going to say 5 to 7 so you can see like little to big. Does that make sense how I wrote it? Little to big, 5 to 7. Okay, and then because I did 5 to 7 with the little one as the 5, I'm going to write my similarity statement that way, so I'm putting the little one first. Does that make sense? 5 to 7? All right, so the little one, and with this one, I can already kind of tell which angles go where. So I've got VWX is similar to triangle UWY.